Hello everyone, welcome to my channel. Today I will show you my Spring Boot POS system. POS means Point of Sale System. This is my assignment project and I am very excited to try it. I will explain it in three parts. First, I explain the important concepts. Second, I show you the live demo. Third, I go through the code. Let's start. First question, what is an API? API stands for Application Programming Interface. Simply, it is how two systems talk to each other. Let me give you an easy example. Think of a restaurant. You are the customer, the kitchen is the database, the waiter is the API. You do not go into the kitchen directly, you tell the waiter what you want. The waiter goes to the kitchen prepares the food, the waiter brings it back. In my project, the front end is the customer, MySQL database is the kitchen, my Spring Boot is the waiter, the API. The front end never touches the database directly. Everything goes through the API. Now, what is a REST API? REST API is a standard way to design APIs. We use HTTP method to say what we want to do. Get, I want to read data. Post, I want to create new data. Put, I want to update data. Delete, I want to delete data. We call these HTTP verbs. So, when the front end sends POS to API, we want customer. Spring Boot understands someone wants to save a new customer. My entire backend is a REST API. It receives HTTP requests, processes them, and sends back a JSON response. Next, what is Postman? Postman is a tool for testing APIs. During development, the front end is not ready yet, but I still need to test my backend. With Postman, I sent HTTP request directly to Spring Boot without any front end. I send a GET request to API v1 customer. I get back a JSON response with all customers. No browser, no JavaScript needed. Now I send a POS request with a JSON body. The response is 201 created. Customer saved successfully. This is how I tested every endpoint during development. Now, AJAX. AJAX means asynchronous JavaScript and XML. Modern AJAX uses JSON, but the name stayed the same. Simply, AJAX allows JavaScript to send requests to the backend without reloading the page. Mm, Look at my system. When I add a customer, the page does not reload. The table updates instantly. That is Ajax working. Without Ajax, every form submit reloads the full page. Very slow, bad experience. With Ajax, JavaScript sends the request in the background, gets the response, update only the part that need to change. Fast and smooth. In my project, all communication between JavaScript and Spring Boot uses Ajax with the fetch function. Now, layered architecture. This is very important. My project is divided into separate layers. Each layer has one job. Each layer talks only to the layer below it. Layer 1 controller. It receives the HTTP request from the front end. That is all it does. Layer 2 service. All business logic is here. Stock calculation, validation, data conversion. This is the brain. Layer 3 repository. It only talks to the database. No logic here. Just save, find, and delete. Layer 4 database. It stores data permanently. Why is this good? If I want to change the database from MySQL to PostgreSQL, I only change the repository layer. The controller and service do not change. Each layer is independent. This is called separation of concerns, a professional software engineering principle. Now, interface implements and extends. Many beginners are confused here. An interface is a contract. It says these methods must exist, but it does not say how, only what. My customer service interface says save customer, get all customers, update customer, delete customer, must exit. Customer service IMPL implements this interface. It writes the actual code, how each method works. Why do we separate them? 3 reasons. Reason 1, flexibility. If I change the implementation, the controller does not change. Reason 2, testability. In unit testing, I can create a fake implementation. This is called mocking. Reason 3, solid principles. Depend on abstractions, not concrete classes. Now, extends. Customer repository extends JPA repository. By extending, it inherits all methods, save, find all, find by ID, ID, delete by ID, all free. Zero SQL code from me. So, to summarize, interface is the contract. Implements is fulfilling the contract. Extends is inheriting from a parent. Before the demo, let me show you the POM XML. These are the libraries my project uses. Spring Boot Starter Web, REST API support, controllers, JSON conversion, everything. Spring Boot Starter Data JPA, Hibernate and repository support, automatic SQL, Spring Boot Starter Validation gives me annotation valid, annotation not blank, annotation min, all validation annotations. MySQL connector connects Spring Boot to MySQL. Lombok removes boilerplate code, annotation getter, annotation setter, annotation required ARCS constructor, model mapper converts DTO to entity automatically. These 6 dependencies together they build the entire backend. Just add to POM XML, Maven downloads everything. Now let me show the live demo. This is the home page of my POS system. From here I can go to customer, item, order and order history. First, customer management. I open developer tools network tab so you can see the real HTTP request. I fill the form, name, address, phone and click save. See, a POST request went to API v1 customer. The request body has JSON data. The response is 201 created. This is Ajax working right here. The customer appears in the table. No page reload. Now I click edit. The form fills automatically with the exiting data. I change the address, click update. See, put request went to API v1 customer. File the number file is the customer ID. Now delete. A delete request went to the same URL, deleted. Full CRUD working. Now, item management. Let me first show validation. I enter -5 as price and submit. See 400. Bad request. Global exception handler. What the validation error? It shows exactly which field failed and why. 0 manual code from me. Now correct data. Price 500, quantity 10, submit. Item saved. Notice I never entered the item cost. It shows 5,000. Calculated automatically. 500 multiplied by 10. The server calculated it. This is business logic in the service layer. Now, order management. This is the core of the POS system. The customer drop-down and item drop-down, they loaded automatically from the database. To get records happen when the page loaded. I select a customer. I select an item. See, the price is filled automatically. The stock badge shows green. I enter quantity 2 and save order. Order saved. 201 created. Now let me go to the item page. Watch the stock of that item. Stock discrete from 10 to 8. The service layer deducted it automatically after the order was saved. Now watch, I try to order 100 but only 8 are available. See, a clear error. Stock not enough. Shows available 8. Requested 100. Order rejected. Stock is protected. Real inventory management. Now, order history. This is a special feature. All orders are here. News first states at the top: total orders, revenue, unique customers, average order value. Now the code. Let me go through each package. My project has a controller, DTO, entity, exception, repository, service, util, and the application class. Every package has one job. The controller is the entry point. Let me explain the PO annotation on top. Annotation REST controller tells Spring this class handles HTTP requests. Return values become JSON automatically. Annotation request mapping AP v1 customer. This is the base URL. I used v1 for the versioning professional practice. Annotation required args constructor. Lombok generates the constructor. Spring uses it to inject customer service. This is constructor injection. This is constructor injection. Annotation cross origin enables cross frontend on port 5500, backend on port 8080, different ports. Browser blocks by default. This annotation allows this request. Now the post method. Annotation post mapping maps HTTP post to this method. Annotation request body takes JSON from the request body, converts to customer DTO automatically. Annotation valid checks all validation rules before the method runs. If any field fails, Spring throws an exception. Global exception handler returns 400. I set DTO sets ID to null. Why? Hibernate checks the ID to decide insert or update. Null means insert. New record database generates the ID. Response entity 201 created. Correct HTTP status for resource creation, not 200, especially 201. Something new was created. DTO, data transfer object. It travels between front-end and back-end. Why not use entity directory? 3 reasons: security, control, validation. Security. Entity might have sensitive fields we don't want to expose. Control. DTO controls exactly what the client can send and receive. Validation. Validation rules go on the DTO, not the entity. DTO is a shell between the outside world and the database objects. Important annotation min only works from integer. For double, you must use the annotation decimal min. Order DTO. Look at item name, total price, order date. No validation. Why? Because the server sets this, not the client. The service fetches item name from the database. It calculates total price. Hibernate set the order date automatically. Entity is the database layer object. One entity class equals one database table. One object equals one row. Annotation entity tells Hibernate map this class to a database table. Annotation ID marks the primary key. Annotation generate value identity. Database auto incremented the ID. I use identity because MySQL has native auto incremented. Order entity. Table name is orders, not order. Critical detail. Order is a received keyword in SQL. If I name the table order, SQL queries break. Always check received keywords. Annotation create time stamp. Hibernate automatically set the current data and time when the order is saved. Updatable false once set. This column can never change in an update. Order date should never change. This annotation enforces it. Customer exception extends runtime exception. Unchecked no truth keyword need anywhere. When something goes wrong in the service, I throw custom exception with a clear message. Global exception handler. Annotation risk controller advice. When any exception is thrown anywhere, Spring checks this class. One place for all error handling. DRY principle. Don't repeat yourself. 3 handles. First, custom exception returns 400 with my error message. Second, method argument not valid exception. When annotation valid fails, I loop through all field errors, put in hash map so frontend gets all errors in one response. Third, generic exception. Catch all. Return 500 Intel server error. Never expose raw exceptions to the client. Customer repository completely empty. No methods, no SQL, but it has all cut operations because it extends JPA repository. JPA repository gives save, find all, find by ID, delete by ID, all free. Spring generates implementation at runtime. Order repository, more interesting custom method using query derivation. Find by customer ID. Spring reads the method name, generates select where customer ID equals automatically. No SQL from me. Find all by order date. Find all order by date. The method name becomes the query. Spring understands it. Service annotation service. Spring register this class as a bean. Business logic lives here. Save customer, one line. Model mapper converts DTO to entity. Repository saves two libraries do all the work. Get all customers, find all return and entity list. Java Stream API. Stream map each entity to DTO. Collect back to list, clean and expensive. Get by ID, find by ID, returns optional or else true. If it exceeds, return it. If not, throw exception. No null pointer errors. Order server IMPL. Most complex. Server order has 6 steps. Step 1. Pass customer ID. Step 2. Check customer exits. Step 3. Find item from database. Step 4. Check stock. If not enough, throw exception. Step 5. Build order entity. Set item name and calculate total price on saver. Step 6. Save order and deduct stock. Delete order. Restore stock before deleting. Always never delete an order without restoring stock. Now, front-end JavaScript. Now, front-end. How JavaScript connect to the backend. Base URL points to the Spring Boot server. Every fetch request uses this. Fetch sends an HTTP request. Return a promise. I use a way to handle it clearly. Content type. Application JSON. Tells Spring Boot the body is JSON. JSON stringify. Convert the JavaScript object to a JSON string. Response comes back. REST JSON, pass it, then REST data because backend wraps everything in API response. ESC HTML function security before displaying server data in HTML. Let me show the complete flow connecting everything. Step 1. User clicks Save Order. Step 2. JavaScript validates the form. Step 3. Fetch send post to API v1 order.ajax. Step 4. Spring Boot controller receives the request. Step 5. Annotation valid. Check the order DTO. Step 6. Controller calls order service. Save order. Step 7. Service validates customer. Check stock. Build entity. Deduct stock. Step 8. Repository calls save. Hibernate generate insert SQL. MySQL saves the row. Step 9. Response travels backup. Step 10. Controller returns 201 plus API response JSON. Step 11. JavaScript receives response, unwraps data, refresh table, reset form, update stock. Every line of code plays a role in this flow. This is full stack development. That is the complete presentation of my Spring Boot POS system, concepts, demo, and full code, everything explained. If this video helped you, please like and subscribe. Thank you so much for watching. See you in the next video.